Example number 20. The graph of a derivative is shown. Find the locations of all extrema of f of x. Now remember, this is the derivative and not the function. We want to know where our derivative is equal to 0, and then we find where our derivative is less than 0, which tells us our function is decreasing. And then we find where our derivative is greater than 0, which tells us our function is increasing. So these two x-intercepts on the derivative graph are the critical numbers. So I'll put my critical numbers on a number line, just like before, 0 and 4. And also recall that when you're looking at derivatives, you're looking at whether they're positive or negative. So this derivative is positive everywhere it's above the x-axis and negative everywhere it's below the x-axis. So that means our derivative is positive to the left of 0, negative between 0 and 4, and positive to the right of 4. So remember what these tell you. These are the slopes of the various tangent lines that are touching the graph only in one place. So we've got positive tangent slopes until we get to where it's 0. Then we got negative tangent slopes to where we get to where it's 0. And then for the rest, we have positive tangent slopes. So we're going to have a maximum here. And remember, these are relative. They're not absolute, because look at this end here. It's going on forever. But this, within this little region here, it's relative maximum. Then we have a low point here, so our relative minimum occurs at x equals 4. So the relative maximum occurs at x equals 0, and the relative minimum occurs at x equals 4.